Something deep in space is sending us a signal. It has no known source, no natural explanation fits, and every passing month, it grows measurably, undeniably stronger. Scientists noticed it first as noise, background interference, a ghost in the data that kept returning with impossible regularity. But ghosts don't get louder. This one does. For decades, astronomers have pointed their most powerful instruments at the darkest corners of the universe. Most of what they hear is silence. Cold, ancient, overwhelming silence stretching across billions of light years. But then there are the anomalies, rare signals that don't belong, patterns buried inside the cosmic background radiation, like fingerprints left inside a locked room. One of them refuses to go away. It was first formally logged in 2010, buried inside data from the Parkes Observatory in Australia. Researchers flagged it as a calibration error. They moved on. They always move on. That was a mistake. Years later, a graduate student named Mia Hendricks was cross-referencing old signal logs from 3 separate radio telescope arrays. She wasn't looking for anything unusual. She found everything unusual. The signal appeared in the Parkes data, then again in logs from the Green Bank telescope in West Virginia, then a third time from an entirely different frequency sweep conducted by the European LOFAR array. Same signature, different years, different continents. Hendricks did what any careful scientist would do. She ran the numbers again. Then she called her advisor. Then she went very quiet for a long time. The signal was not only consistent, it was intensifying. Radio signals from space are not new. We have catalogued pulsars, magnetars, fast radio bursts, and quasars. We understand their physics. We can model their behavior. This signal matched none of those categories. A pulsar produces bursts with clockwork precision. Their rhythm comes from spinning neutron stars, dense and predictable as a metronome. This signal had rhythm, yes, but that rhythm was evolving. It was changing. It was learning. That word, learning, is not scientific language. Scientists are careful. They choose words the way surgeons choose instruments. But behind closed conference doors, more than one researcher used exactly that word. Learning, adapting, responding. The signal repeats every 73.4 seconds. That interval has remained constant, but the amplitude, the sheer power behind each pulse, has grown by a measurable 0.3% every 6 months since reliable records began in 2014. That is not normal. That is extraordinary. To understand why this matters, you need to understand what 0.3% growth means across deep space. Signal strength drops with distance. It always does. For anything natural, signals weaken over time. They dissipate. They scatter. They fade into the background noise of a cooling universe. A signal that grows stronger is a signal moving closer, or a signal being deliberately amplified. Those are the only 2 options physics allows. Both of those options will keep you awake at night if you think about them long enough. Astronomers triangulated the source. They used data from 17 separate telescope arrays across 4 continents. The math took 18 months. The result was simultaneously clarifying and deeply unsettling. The signal originates from a region of space, approximately 1.3 billion light-years from Earth. That distance alone should silence any speculation about proximity. But the signal is growing stronger despite that distance. That should be impossible. At 1.3 billion light-years, you are looking at light and radio waves that left their source before complex animal life existed on this planet. You are receiving a message from the deep past, a past that is somehow becoming louder in our present. The region of origin is not empty. It sits adjacent to a massive galactic filament, one of those enormous cosmic structures made of dark matter and gas that connects galaxy clusters like threads in a web stretching across the universe. These filaments are among the largest known structures in existence. They dwarf individual galaxies the way a coastline dwarfs a single grain of sand. What happens inside them is still poorly understood. That uncertainty is important. Remember it. Some researchers proposed a natural explanation almost immediately. Plasma lensing. The idea is that dense clouds of ionized gas between us and the source could act like a lens, focusing and amplifying the signal as the plasma shifts over time. It is a reasonable hypothesis. It is elegant, in fact. The problem is that plasma lensing produces a specific spectral fingerprint. The amplified signal should show characteristic frequency distortions. This signal shows none of those distortions. It arrives clean, perfectly clean. A perfectly clean signal across 1.3 billion light-years is, in itself, a scientific curiosity worth years of study. Interstellar space is filled with dust, gas, magnetic fields, and gravitational interference. Signals smear, they blur, they distort. This one does not. In 2019, a team at the Max Planck Institute for Radio Astronomy in Bonn published a paper analyzing the signal's spectral coherence. Their conclusion was careful and scientific, and still somehow stunning. They wrote that the signal showed, quote, anomalous phase stability inconsistent with known astrophysical propagation mechanisms. Anomalous phase stability, in plain language, that means the signal is holding itself together across impossible distances in ways that physics cannot fully explain. Like a candle burning in a hurricane without flickering. Something is wrong, or something is very, very right. The paper received significant attention in academic circles. It received almost none in mainstream media. This is how science often works. The most unsettling discoveries move quietly, peer-reviewed and discussed in papers most people will never read. Then came 2022. A new survey instrument came online. Part of the Square Kilometre Array precursor project operating from Western Australia. It had sensitivity levels that made previous instruments look like tin cans on strings. Within 3 months of training on the signal's coordinates, new instrument confirmed everything and added something new. The signal was not a single pulse. It was 2 pulses, separated by exactly 0.017 seconds, repeating together every 73.4 seconds without deviation. 2 pulses, not 1. That detail matters enormously. A single pulse from a natural source can be explained. A double pulse, perfectly timed, separated by a precise fraction of a second, repeating across years without drift, is significantly harder to explain away. The scientific community fractured into camps. One camp, the larger and more publicly visible one, insisted on exhausting every natural explanation before drawing any extraordinary conclusions. That is good science. That is how it should work. The second camp was quieter. They published less. They spoke in hallways at conferences. They asked questions that made the first camp uncomfortable. What if we are not looking for the right kind of natural explanation? What if the category we need does not yet exist? There is a concept in science called unknown unknowns. These are the things you do not know that you do not know. Flat Earth thinkers cannot conceive of orbital mechanics. Medieval physicians cannot conceive of germ theory. We are always working inside the limits of our own conceptual frameworks. What if this signal exists in a category of physics we have not yet named? What if it operates by rules we have not yet discovered? What if our instruments are detecting the edge of something vast, and we are calling it noise because we have no other word? These are not comfortable questions. Science does not like them, but science also cannot afford to ignore them. Every major revolution in our understanding of the universe began with someone refusing to explain away the thing that should not be there. Copernicus refused to explain away the orbits. Darwin refused to explain away the fossils. Einstein refused to explain away the anomaly in Mercury's perihelion. Every one of them was inconvenient for the science of their time. Every one of them was eventually proven right. In late 2023, a research group associated with the SETI Institute began a dedicated listening campaign targeting the signal's coordinates. SETI, the Search for Extraterrestrial Intelligence, is an organization that has spent decades being treated as fringe science by mainstream academia. That perception has shifted. Quietly and significantly, respected astrophysicists have begun consulting with SETI researchers, not because they believe the signal is artificial, because they believe they cannot rule it out without more data. That is a stunning shift in posture. The SETI listening campaign used the Allen Telescope Array in California. After 6 months, the team published a preliminary report that received almost no media coverage and deserves significantly more attention than it received. The report noted that the double pulse structure of the signal contained what appeared to be embedded mathematical relationships, specifically, the ratio of the pulse durations to the interval between them, approximated, within measurement error. The value of the mathematical constant pi, the ratio of a circle's circumference to its diameter, a universal constant that any mathematically sophisticated intelligence would recognize, a constant that does not appear in signal structures produced by known natural astrophysical processes. The team was careful, enormously careful. They used qualifiers like appears to suggest, and within the limits of current resolution, they did not claim anything. They reported what the data showed. the data showed something very strange. Critics responded quickly. Random noise can produce apparent mathematical patterns. Human brains are extraordinarily good at finding patterns, even where none exist. Apophenia, the tendency to perceive meaningful connections in unrelated things, is a documented cognitive bias. The critics are correct to raise this, but the critics face a problem. The pattern is not subtle. It is not the kind of thing where you squint and sort of see it. The ratio holds across multiple independent measurements taken by instruments on different continents over several years. Noise does not do that. As of early 2025, the signal has been verified by 23 independent research groups across 11 countries. Every group confirms the same core facts. It repeats on the same interval. It is growing stronger. It is remarkably coherent. Its internal structure contains unexplained mathematical relationships. 23 independent groups. That is not a calibration error. That is not wishful thinking. That is a reproducible scientific observation that the entire global astronomical community has now confirmed and has not been able to explain. The question of what it is remains genuinely open. That openness is itself significant. We live in an era of extraordinary scientific capability. We have mapped the cosmic microwave background to extraordinary precision. We have detected gravitational waves from black hole mergers a billion light years away. We know an enormous amount. And yet this signal sits there, strengthening, patient, structured, and completely outside the boundaries of our current understanding. It does not care whether we can explain it. It simply continues. There are people in laboratories right now, brilliant and careful people who have devoted their lives to understanding the universe, staring at this data every day. They go home and they lie awake, not because they are afraid, because they are scientists and something is not adding up. What happens if the signal continues to strengthen? What happens in 10 years, or 20, when it has grown by another several percent? At some point, the amplitude crosses a threshold. At some point, it becomes impossible to attribute to any known amplification mechanism. At some point, you have to consider the other possibility, not with excitement, not with science fiction fantasy, but with the cold, careful, mathematically rigorous consideration that the data demands. Something is out there. Something is producing this, and it is becoming easier to detect. If it is artificial, then the implications are staggering beyond comprehension. We would not be alone. We would have company in a universe we thought was empty. Company that has been broadcasting for longer than our species has existed. If it is natural, then we are witnessing a new category of astrophysical phenomenon unlike anything previously recorded. Something that strengthens over time. Something that preserves signal integrity across cosmic distances. Something with internal mathematical structure that we cannot yet explain. Either answer changes everything. Either answer rewrites textbooks. Either answer sits waiting inside those data logs, patient and certain of its own existence, while we run the numbers one more time, and then one more time after that. The universe is under no obligation to be comprehensible to us. It operated for 13 billion years before we arrived to ask questions about it. It will operate for billions more after we are gone. We are new here, we are small, and something out there just made itself a little easier to hear. That 0.3% growth every 6 months means the signal doubles in effective detectable strength roughly every 100 years. In the time since the first radio telescopes were built, we have gone from not detecting it at all to hearing it clearly across 23 independent observatories. What does it sound like in another 100 years? Another 500? If the growth continues, eventually it will not require a telescope at all. Eventually, it will be everywhere. A message encoded in space itself, delivered slowly, deliberately, across geological time, to whoever is patient enough to listen. We are listening now. The signal is growing. It has a structure that defies easy explanation. It has a precision that defies casual dismissal. It has a patience that suggests whatever produces it operates on timescales we can barely imagine. And every 73.4 seconds, without fail, it pulses again, twice, separated by 0.017 seconds. Perfectly coherent, perfectly clean, perfectly maddeningly, beautifully unexplained, right on schedule, growing louder, getting clearer, waiting to be understood. We are left with a universe that contains something we cannot yet name, something that predates us, something that has been calling out across a billion light years of silence while we were still learning to stand upright on a small blue planet circling an ordinary star. You are alive in the moment when the signal is becoming undeniable. You are alive in the moment before we know what it is. You are standing at the edge of a discovery that may define not just a generation, but the entire arc of human civilization. That is where we are right now. The only question left is the one that every scientist, every philosopher, every sleepless researcher staring at frequency plots at 3 in the morning keeps asking themselves. The question that has no answer yet. The question the signal refuses to answer for us. What is it? What is really out there? And if it knows we are here, what comes next? We want to know what you think. Drop your answer in the comments below. What do you believe this signal really is? And if you want to keep exploring the questions that science hasn't answered yet, subscribe and stay with us. The universe is just getting started.